Okay, in this video, we're going to continue working on the 6.2 practice, day 1. And we're going to start where we left off on problem number 5. So here they say, find the triangle lengths represented by the sides highlighted in red and green. Okay, I look at that and I say, I can't see any values of side lengths in the left-hand triangle. So I'm going to use this altitude, and this is the altitude right here. So let me just highlight that a little bit. Okay, so this right here is your altitude. I'm going to use that as the bridge between the two triangles. So look what I can do. From this angle's perspective, I can see that I have the hypotenuse, and I want this. I'm going to make this x. I want the altitude, which is the opposite. So opposite and hypotenuse tells me to use sine. So sine of 33 degrees equals opposite over hypotenuse. And then I'm going to do my cross products. Oops, sorry, I'm good. I'm going to do cross products, 22 times the sine of 33 degrees, and I end up putting that in my calculator, and I get the fact that my x will equal about 11.98. Okay, so if this is 11.98, I'm going to use that now to get information on the red and the green. So if I want to do the red, I'm going to say, from this point of view, I have this, and I need the hypotenuse. So the sine of 47 equals opposite 11.98 over, we'll just call it red, over red. Okay, so red times the sine of 47 equals 11.98, and red therefore is going to equal 11.98 over sine of 47. And I get red to be equal to 16.38. So this is now 16.38. Okay, let's try to get green now. So if I use that same angle 47, I want to get the green piece down here. So I'm going to say the tan of 47, because that's going to equal opposite, which is what I have, over adjacent, which is what I need. So cross products, green, tan 47 equals 11.98. Green equals 11.98 over the tan of 47. And that's going to give me my green equal to 11.17. 11.17. So you definitely should know how to do this kind of problem where you have to use a connecting piece, so that you can find that information about the other triangle. Okay, so that's a reflexive property. Okay, so moving on. Now they say different problem. I'm not asking you to find all 6 trig functions in these problems in the box. I instead just want you to find the pieces that are missing. So you are basically solving for the right triangle. So let's find out what's missing. So for each of these, I can see this is missing, and I don't have this angle right here. Easiest thing to do is to get the angle. I know that the two acute angles in a right triangle are complementary. So therefore 90 minus 47, and I'm in degrees, will give me the missing angle, which is 43 degrees. So that is done. I have solved that problem. Now, I would suggest that you use the angle they gave you to find the missing pieces. So I like to have a system in place. So I'm going to write down SOHCAHTOA, and I'm going to say from that angle's perspective, the 47, I have only been given the opposite. So opposite is included in sine and in tan. That means I'm going to use those 2 trig functions to get the missing pieces. So let's go ahead and do that. So if I say the sine of 47. That's going to be 6 over the missing side C. So C times the sine of 47 equals 6. So C is going to be 6 over the sine of 47. And I am getting 8.2 for that. Remember, your calculator is in degree mode. All right, let's get the other. So if I use the other highlighted trig function, which is tan, the tan of 47 degrees. Hang on one second. Okay, we're back. Okay, so tan of 47, what's that going to equal? It's going to equal 6, the opposite, over the A, which is what we're looking for. So do the same cross products that we've been doing and isolate your A by dividing both sides by tan 47. And I got, what did I get for A? I got 5.6 for my A. All right, so check that. Make sure you can get those answers. Number 7 is exactly the same type of problem. So you're going to get your angle first. And to get that angle, and now I can call it angle A, is 90 minus 50, which is 40 degrees. So this is 40 degrees. That was missing. This is missing, and this is missing. All right, so I'm going to write down SOHCAHTOA. So I have SOHCAHTOA. And I'm going to highlight that. And I'm going to say, okay, SOHCAHTOA, I've been given the angle of 50. From angle 50's perspective, that side of 23 is the adjacent. So this is adjacent, and this is adjacent. So I can use cosine and tan to find the missing values. All right, so I'm going to do this. I'm going to say the sine of 50. Oh, sorry, so crazy. I'm going to do cosine because I just pointed out that I have to do cosine. So the cosine of 50 is going to be 23 over the hypotenuse, which is the C. So C times the cosine of 50 equals 23. Isolate your C, divide both sides by cosine of 50. And when I did that, I got C is 35.8. 35, let me make that 5 better, 35.8. Now, that should be the largest side because that is the hypotenuse. So that falls under my reasonableness test, which we'll talk about in just a second. Okay, the tan of 50 degrees is going to equal opposite, which is B, over the 23. Now, this is a one-step problem because when I do my cross products, I get the answer right away, tan of 50. And so my answer is going to be that B equals 27.4. So this is 27.4. Okay, are these answers reasonable? Well, the bigger the angle, the bigger the side, and that follows with my answers that I got. So therefore, those answers are reasonable. I don't see any glaring error that I'd have to reconsider my work. Okay, 8 and 9. 8 and 9, you've got to keep things in radians. If I give it to you in radians, I want it in radians. All right, so what's missing? Well, I have an angle missing here. I have a side missing here, and I have a side missing here. So the first thing you're going to do is put your calculator in radian mode. Okay, so I'm going to say radians for both of these. Okay, missing angle. Just like above, the two acute angles add to 90. 90 in radians is pi over 2. So to find our missing angle, I'm just going to say pi over 8, pi over 2, that's 90, minus pi over 8 equals the missing angle. Well, I can't do anything with it until I get pi over 8 to work with. I do that by multiplying by 4 over 4. This is 4 pi over 8 minus pi over 8, which is really 1 pi over 8. That gives me 3 pi over 8. So this missing angle right here is 3 pi over 8, and that's all we have to do with that. Okay, so then I always like to do my little SOHCAHTOA, so I'm going to do that here. SOHCAHTOA. And I'm going to say to myself, okay, from the angle they gave me, which was this B angle, they only have given me the hypotenuse. So I'm going to highlight wherever hypotenuse shows up. So that's telling me that I'm going to use sine and cosine to solve for the missing values. So the sine of pi over 8, remember you're in radians, is going to equal B over 17. Okay, I'm not going to write out my cross products in the interest of time. So 17 times that equals 8 times B. Isolate your B just like we've always done, and you should be getting B equals 6.5. So that's 6.5. Okay, now let's go for the remaining missing side, which is the A side. So we're going to say that's going to be your cosine, right? So the cosine of pi over 8 equals A over 17. Same types of cross products. The A you're getting should be 15.7. So this is 15.7. Now, does this seem reasonable? Well, 17 is the biggest side, and 17 is across from pi over 2, or 90, so that's the biggest angle. So that's good. Clearly, 3 pi over 8 has to be bigger than pi over 8, and it makes sense because 15.7 is bigger than 6.5. Remember, big angles generate big sides. So that all seems reasonable, and I can go on to the next problem. Okay, same thing. Keep it in radians. Do not fear that radian angle. It's not going to impact anything. It's just going to, you're going to work with it to get your missing angle, which is this angle here. So that's missing, this is missing, and this is missing. Okay, easiest thing is to get that angle. So we're going to say pi over 2 minus 5 pi over 14. Multiply pi over 2 by 7 over 7. That's going to give me 7 pi over 14 minus 5 pi over 14 equals 2 pi over 14, which just equals pi over 7. This missing angle is pi over 7, done. Okay, so now I'm going to go back and I'm going to write SOHCAHTOA, and you don't have to do this if you have your own way of doing it, but I'll tell you, this will solve a lot of overthinking. From the angle they gave me's perspective, I have been given only the opposite. Opposite is involved with sine and with tan. So I know that I can take my sine of the 5 pi over 14, and that's going to equal opposite over the hypotenuse. Cross products again, C is going to be 13.3. Then move to your tan. The tan of the angle they gave me equals opposite, and that's going to be the 12 over the A that's missing. Cross products again, and you get 5.8, and we're done. That brings us to 10. Looking at 10, I see I have a ladder problem. I also see they want me to round my answers to 1 decimal place. So take your calculator off float and put it to 1. I see right here I have degrees, so I'm going to be in degree mode. So you have to be the master of that calculator. Okay, a ladder is placed against the side of a building, making an angle of elevation of 53 degrees. So let's see if we can get that little sketch. And here's my ladder. Okay, remember these are all going to be right triangles. So there is my right triangle sketch. Now you've got to figure out, right here is your ladder. All right, your ladder is leaning against the wall. Then I'm going to read my problem. A ladder is placed against the side of a building. Okay, so that means that this over here must be my building. Okay, so illustrate these things for yourself just so you know what's going on. Then it says it's making an angle of elevation of 53 degrees. That means that this is where the angle of elevation is. When you look up to the top of the building, that is 53 degrees. They also say the top of the ladder touches the building at a spot 26 feet above the ground. 26 is the height of the building that we're concerned with. Okay, maybe I drew my building as if that's the very top. It doesn't really matter how I drew it. 26 is the number that we want to have for the vertical height. Okay, how long is the ladder? So the ladder's on the hypotenuse, right? It's right across from here. Okay, so from what they've given me so far, I'm going to do my little SOHCAHTOA again. So we'll do it over here, get it out of the way. And I know I have a ladder. So really, anything that has hypotenuse in it, I can solve by using my ladder measurement. Oh, excuse me. Take that back. Let me rephrase that. I have been given the opposite. So what includes the opposite? This is opposite. This is opposite. I need to find the hypotenuse. I'm going to use sine, because sine will get me the ladder length, which is the hypotenuse. All right, so now let's do that. So the sine of 53 will equal 26 over that ladder. Okay, do your cross products, and you're going to get your ladder ends up being 32.6 feet. So this is 32.6 feet. How far away is the base of the ladder from the building? Okay, so right here, this is the base of the ladder. This is the building. So doing that lets me know that what they're looking for is this length right here. We'll call this Y. They're looking for Y. Okay, so from 53 degrees point of view, that is the adjacent, and I have the opposite. That looks like it's tan. Tan of 53 equals opposite, which is the 26, over the Y. Okay, do your cross products, and your Y should end up being 19.6 feet. So this is 19.6 feet. Now, does this seem reasonable? Well, 53 degrees is going to be the bigger of the two acute angles. The other one's going to be what? Think about that. What's it going to be? 37, perhaps? So that makes sense that 26 is greater than the 19.6, and the ladder should be the biggest number because that's the hypotenuse. So my measurements or my calculations seem good. All right, so I'm going to move on. Okay, here's the first time we've seen the angle of depression concept. So let's look at that carefully. A support cable runs from the top of a 125-foot tall building. Okay, so here's your right triangle. Again, here's the building, and this is the tippy top of the building. Okay, and here's the cable. And this building was 125 feet to a stake in the ground. Here is the stake. The angle of depression for the cable is 71 degrees. That means that you are looking out from the top and looking down. This is the angle that's 71 degrees. Because this horizon and this horizon are parallel, and the cable is acting as a divider of parallel lines, the transversal, what I know is that my angle of depression equals the angle of elevation down here, and that puts that measurement inside the triangle, which is going to help me. They want to know how long is the cable and how far away from the building is the stake. So here are the two things they want. We'll call this X, and we'll call this just C. Okay, once again, I'm going to do my SOHCAHTOA. and I'm going to say, okay, they gave me the opposite of the angle in question. And that's all they have. I have that 125. So that's opposite. So that's telling me that I can use sine and tan to solve for missing pieces. So I'm going to say, let's get the cable first. So that's the sine of 71 equals opposite 125 over C for cable. Do your cross products, and you should get that your cable is 132.2 feet. Okay, moving to the next one, I want to find out the x. So that's going to be my tan. So the tan of 71 equals opposite, which is 125 over the x. Again, cross products, x, I'll show you another one, 71 equals 125. Isolate your x, divide both sides by tan 71, and you're going to get an x value of 43. So this is 43. Okay, that seems reasonable because 71 is one angle. That's a very large acute angle. It's across from a large building size of 125. The cable has to be the largest because it is the hypotenuse, and it is. And 43 should be the smallest of the three, and it is. So I am good to go. Okay, I like this problem a lot, the banner problem. So let's talk about that. A banner hangs down from the top of a tall building. Okay, so you're going to kind of draw this way. Here's your building. Okay. I think that's really horizontal, but that's okay. Okay, so your banner is hanging down from the building. So this is your banner. Okay, this is the banner. And then it says, you are standing 200 feet away from the bottom of the building. So that means that this distance right here, and this is where you are, is 200 feet. Okay, so then it says, your angle of elevation to the bottom of the banner is 36 degrees. Okay, so draw that. So your angle of elevation to the bottom of the banner. So here's the bottom. There's your angle of elevation, and what is it? 36 degrees. Okay, your angle of elevation to the top of the banner. So now you're going to look up higher. So when you look up higher, look what's going to happen. You're looking up here, but you have not moved. So you are in the exact same spot. So this angle right here, from here to here, that big angle is now the new angle of elevation to the top of the banner. So I have two angles inside this triangle. Now look, that's 200 feet is common to both. And that 200 feet is an adjacent. They want to know a couple of things. They want to know how tall is the building. So the first thing they want, and maybe we'll do this in green. They want to know how tall is the building. Okay, how tall is the building? So you want the whole length right here. So you're going to use what? The 51 degree, because that lets you look up to the top of the building. Because remember, the top of the building and the top of the banner are the same place. So that's one thing. Then they want to know how tall is the banner. So we're going to talk about that in a second. Let's work on A first. How tall is the building? So SOHCAHTOA tells me it's going to be tan. The tan of 51 equals this building. So I'm going to say building, because that's opposite, over 200. One step problem. 200 times 1051 will give me my building. And my building ends up being 247 feet tall. Okay, so this is 247 feet. So right here, this is 247 feet from here to here. Okay, we have another triangle. Where is that triangle? That's this one in here. I can figure out how far it is from the bottom of the building to the bottom of the banner. So I want to figure out this red line right here. I'm going to use the angle of 36. It's still going to be a tan. I've got to do a couple of things. So the tan of 36 equals, I'm just going to say purple. We'll call this purple. Purple over 200. Again, one step problem. So what am I finding? I'm finding that the purple piece right here, when I do that multiplication, and I'm in degrees, is 145.3. Okay, so that means right here is 145.3. But they don't want that, do they? They want to know the size of the banner. So they really want to know, and we'll do this in blue, they want to know just this. So you need to figure out the blue. So blue equals the banner height, how tall it is. So to get the banner height, you're going to take the building, which is 247, minus the bottom of the banner, which is 145.3, and that's going to equal your banner height, which is 101.7 feet. Okay, so this is 101.7 feet, and then we're done. Okay, all right, that brings us to 13. You are standing still looking at the top of a flag that's 47 feet tall. So if I'm standing like this, and you're standing still, okay, so this flagpole is 47 feet, so he'll give it a little flag, and your angle of elevation is 74. So this is where we are initially. You now walk further away. You walk further away, and then you turn around and you look up again, and you find that your angle of elevation is now 63. Okay, so this is the right triangle. This is now 63. They want to know, how far did you walk? That's what's missing. So what do you know so far? I have two angles of elevations, and I have the opposite. I need a lot of adjacent values. So I'm going to start off using tan. So the tan of 74 equals opposite, which is 47 over, we'll call that x. So we'll call this x from here to here. Okay, you're in degrees, two-step problem, solve for x, you end up getting x is 13.5 feet. Okay, next one. You're now going to figure out where you are after you stopped walking. And so what you're going to do is you're going to use the tan of 63, and that's going to equal 47 over, so we'll call this y, okay? So over x plus y. Don't put anything in there. Just leave it as x plus y. So let's solve for x plus y. X plus y will eventually equal 47 over the tan of 63. Okay? X plus y is going to equal 23.9 feet. So since x plus y equals 23.9 feet, and x equals 13.5, do a subtraction, and what do you get? 10.4 feet has to equal y. Okay, so that's how I did that one. Okay, that brings us to 14. Okay, you are standing on the sidewalk between two buildings. I like this one too. So here are your two buildings. You've got one that's 200, and then here I am standing in between, and I have another one that's 170, right? So this one, building on my left, is 200 from here to here, and my right is 170, and where am I standing? Just someplace between it. Okay, I'm going to put it here, but it's not required that it's in the middle. When I look at the building on my right, my angle of elevation is 18 degrees. When I look at the building on my left, my angle of elevation is 27 degrees. How far apart are the two buildings? So I think you need to figure out this distance right here, and then you need to figure out this distance right here and add them together. Okay, so let's get the red one first. So from this angle's point of view, the tan of 27 equals 200 over the red line. So I find that my red line ends up being what? I think it's 392.5 feet. So this is 392.5. Okay, then I'm going to do the green. The tan of 18 equals 170 over green. So green equals two-step problem. Green equals what? I think I got 523.2 feet. So this is 523.2 feet. Add them together. Okay, so how far apart are they? So you're going to say 392.5 plus 523.2. That's 0.7519. Okay, so that's how many feet apart they are. And I just added up these two distances. So drawing this is half the battle. So draw very carefully. Okay, two more problems to go in this video. Okay, you are standing on the ground 1,500 feet away from the base of a building. Okay, so here I am, and I'm standing 1,500 feet away from the base of a building. Okay, so that from here to here is 1,500. Okay, and this is the building. All right, what else do I know? Your angle of elevation to the top of the building is 18 degrees. So this is 18 degrees. You now start walking towards the building. So you're going to walk this way. So initially you were here, and now I'm going to go that way. And stop walking after 20 seconds. At this new location, your angle of elevation to the top of the building is 27. You've got to draw another line. Now you look up. Okay, you stop walking, say here. This is now 27. How tall is the building, and how far did you walk? Okay, so I know that this is 90 degrees right here. So I'm going to use the big triangle to figure out the height of the building. That means I'm going to use 18 degrees since that's with the big triangle. And since it's opposite of adjacent, it's tan. So the tan of 18 degrees equals opposite, and we'll say that's your x over 1,500. Okay, one-step problem. I end up getting x is 487.4. So this is 487.4. Okay, so that's helpful. So now, can't I get another value? Can't I get y? So I'm going to get y using the other triangle. Remember, you can only use right triangles. So you can't use that triangle to the right because that triangle is not a right triangle. So I'm going to say now the tan of 27 equals opposite is the height I just discovered over the y that I can get by using my right angle trig. And I end up that y is 955.8. Okay, so right here is 955.8. So how far did you walk? So you walk, so let me not do that color. So your walk ends up being, you were 1,500 feet away. When you stop, you're only 955.8 feet away. So how far did you travel? 544.20 feet. That's the distance that you traveled. Okay, and that would be this number right here. Okay, so that brings us to my favorite problem, number 16. And 16, you've got a fair amount of work to do, but you have to first get a good drawing. So let's do that. So here's my building. All right. You need to run 2 different cables from stakes in the ground to the top of the building. The 2 stakes are separated by 100 feet along the ground. Okay, so I'm going to draw 2 stakes up to the top of this building. Here's one wire. Here's one stake right here. Okay, and then here is another. Let's say it's coming from here. Okay, and I know that this distance right here, so this red distance is 100. I then know that the furthest stake, the angle of elevation from the closer stake, is 48. So this is 48. And then from the furthest one, this is 41. Okay, so I need to figure out the height of the building. So I want to figure out x. X is the height of this building. So I don't have a right triangle that has given me a leg or a hypotenuse. So I'm going to write out what I'm thinking and then see where I can go with that. Okay, so a couple of things. Let's call, well, actually, I think I'm going to call this vertical section y. Let's call this y. Let me back out of there. Let me call, this is going to be y. So make that y, and we're going to make this piece right here x. Okay, so that's what I have going on. Then this is going to be wire 1, and this will be wire 2. Okay, let's figure out if we can get the top of the building. Well, I know it's going to be all tan stuff, so what do I have? So the tan of 41 is going to equal opposite, which is y, over adjacent. Now, adjacent is going to be 100 plus x. Then I also know that the tan of 48 is going to be y over x. Okay, what do they have in common? Well, they clearly have that y in common. So let's do the cross products. So 100 plus x times the tan of 41 is going to equal x times the tan of 48, right? Because they both equal y. So maybe I won't jump to that. So hold on. This equals y. What else equals y? tan 48 times x equals y. Since they both equal y, let's just set them equal to each other. Okay, easy enough. Not the way we usually solve things, because we usually get numbers quicker, but that's okay. So let's divide both sides by, I think I moved tan 48, tan 48, tan 48. What does that give me? Well, I'm also going to move the other, but I'm going to do it in 2 steps. So now I have 100 plus x times the tan of 41 over the tan of 48 equals x. All right, why not move 100 plus x, 100 plus x, that's gone. Okay, tan 41 over tan 48 in your calculator, that's going to equal 0.8. 0.8 equals x over 100 plus x. Do your cross products. 0.8 times 100 is going to be 80 plus 0.8x equals x. Subtract 0.8x, subtract 0.8x. 80 equals 0.2x. Divide by 0.2, divide by 0.2. X is going to be 400. Okay, so this x is 400. Now they want to know the wires. So look at, let's do wire 1 first. So we're going to find wire 1. Wire 1. I can use the small triangle now, and I can say that the tan of 48 equals, well, here, hold on a second. I have to do one more thing. What didn't I find yet? I didn't figure out the height of the building, right? That was the whole reason. I'll get the wires in just a second. So hang on to this. Let's get y now. Do the easier of the two. Isn't it true that y equals tan 48 times x? Now I know that x is 400. So I'm getting my y to be, my y is going to be 444.2 feet. So this building is 442.4 feet tall. Now let's get my wires. Use the small triangle to the left, and wire 1 will be our focus. Let's use what? Let's use, since I don't have, I'm going to use cosine. The cosine of 48 equals 400 over wire 1. Wire 1, after I do my cross products, will be 597.8 feet. Let's get wire 2. Use the big triangle. The cosine of 41 equals not 400, but 500 over wire 2. Wire 2 will therefore equal 662.5 feet. And we are done. Okay, so 16 is a really good problem. It's a little bit creative, but that's okay. Math is sometimes allows for creativity also. It's not all cut and dry. So that's the end of this package. You have 2 videos for it. I hope that helped.